By 2050, our world will be running on a completely new kind of intelligence. It won't be purely human, and it won't be the artificial intelligence we know today. It's a hybrid, a fusion of quantum computing and artificial intelligence, and it's poised to solve problems we currently think are impossible. This isn't just another tech upgrade, it's a fundamental rewrite of reality itself, and it's already starting. Forget an artificial intelligence that just predicts traffic. Imagine an artificial intelligence that simulates every single molecule in your body's cells in real time to design a cure for a disease before you even have symptoms. That is the promise of this revolution, one that's quietly unfolding in labs all across the globe. For decades, we've lived by the steady drumbeat of classical computing, Moore's law, powered by bits, the simple zeros and ones that built our digital world. But we're starting to hit a wall. The challenges we face now, from developing new medicines to fighting climate change, involve a kind of complexity that our best supercomputers just can't handle. This is where quantum computing crashes the party. And it's not just a polite upgrade, it's a complete break from the past. A classical computer uses bits. A quantum computer, on the other hand, uses qubits. Thanks to a wild principle called superposition, a qubit can be a 0, a 1, or somehow both at the same time. Then, when you link these qubits together through another bizarre property called entanglement, their power grows exponentially. 2 qubits can explore 4 possibilities at once. 3 can explore 8. A few hundred entangled qubits could, in theory, perform more calculations simultaneously than there are atoms in the known universe. Now, all that power is just raw potential, sort of like a Ferrari engine without a car. The car, the intelligence that can actually steer that power, is artificial intelligence. And when you put the two together, things get really interesting. Artificial intelligence's biggest bottleneck has always been raw computing power. Training today's massive artificial intelligence models takes huge amounts of time and energy. For example, training a model like GPT-3 required over 1,200 megawatt hours of electricity. Quantum computing promises to turbocharge that process. This combination creates a new kind of hybrid intelligence, where the real genius isn't just building bigger quantum processors, but making them work together with classical computers. This synergy is expected to create a massive market, with some analysts projecting the quantum artificial intelligence market could grow from around $280 million in 2024 to over $7.7 billion by 2035. So, what are these impossible problems? Let's talk about designing a new drug. A single protein molecule can have a staggering number of ways it could fold, but only one shape is the right one. A classical computer would have to check every single possibility one by one. That's like trying to find one specific grain of sand on every beach on Earth, a process that could take thousands of years. This is what's known as a problem of exponential complexity, and you see it everywhere. In logistics, it's finding the absolute most efficient route for a global shipping network with thousands of moving parts. In finance, it's modeling every flicker in the global economy at once to see the next crisis coming before it hits. In material science, it's designing a new catalyst for clean energy or a room temperature superconductor. That requires simulating how electrons behave at a quantum level, something classical computers can only guess at. Our current technology is bumping its head on the ceiling of what's possible. Even with artificial intelligence, we're mostly just finding clever shortcuts for problems we can't truly solve. Our artificial intelligence models are getting stronger, but they're also becoming absurdly expensive to train, both in dollars and in energy. The computational power needed for top-tier artificial intelligence models has been doubling every few months, far outpacing Moore's law. We're simply running out of road with classical bits. The quantum era isn't about shortcuts, it's about building a whole new highway. The fusion of quantum and artificial intelligence isn't one single fix. It's a master key that unlocks thousands of different doors. And this hybrid approach is already moving from theory to reality in labs and early applications. Here's a glimpse of how this could reshape our world by 2050. First, in medicine. Instead of spending years on trial and error, a quantum artificial intelligence hybrid could simulate millions of potential drug molecules interacting with a disease protein all at once. This would let scientists design a perfect drug for a specific illness, or even a specific person, in a fraction of the time. We're already seeing the first hints of this, as pharmaceutical companies like Merck and research institutions like the Cleveland Clinic are using early-stage quantum platforms to screen for new drug candidates for diseases like Alzheimer's, aiming to slash research timelines. By 2050, this could mean personalized cancer therapies designed in hours, not years, based on a quantum simulation of your unique body. Next, in finance. Global markets are a chaotic storm of interconnected variables. A quantum artificial intelligence could analyze every possible market storm in real time, creating financial models that aren't just predictive, but practically prescient. It could spot complex fraud patterns that are totally invisible to today's algorithms, making our financial systems more stable and secure. And then there's materials science. The hunt for revolutionary new materials, think high-temperature superconductors or hyper-efficient solar panels, is currently a slow, painstaking process of trial and error. Quantum artificial intelligence will let us design these materials from the atoms up. By perfectly simulating quantum interactions, we could discover materials that enable power grids with zero energy loss, transform energy storage, and help build a truly sustainable world. The common thread here is simulation. Quantum computers are naturally brilliant at simulating other quantum systems, a task where classical computers will always be out of their depth. Artificial intelligence is the guide, directing those simulations and translating their results into world-changing discoveries. Painting a picture of 2050 means we need both imagination and a serious dose of realism. Right now, we are in what's called the noisy intermediate scale quantum, or NISQ era, a term coined by physicist John Preskill. Today's qubits are incredibly fragile and easily thrown off by the tiniest disturbance like heat or a stray vibration, which limits the scale of reliable computations. To get from here to that 2050 vision, we have to solve a monumental engineering challenge: quantum error correction. The solution is the logical qubit. Think of it as a near-perfect, error-proofed qubit that's built by encoding its information across many physical, error-prone qubits. For a long time, the overhead was thought to be massive, maybe 1,000 physical qubits for just one logical one. While that ratio is improving, building a truly fault-tolerant quantum computer, one that can fix errors faster than they appear, is the central mission for the next couple of decades. Companies are on aggressive roadmaps, with IBM aiming to build a large-scale fault-tolerant system named Quantum Starling by 2029. Google has also made huge strides, demonstrating in a 2023 paper for Nature that encoding information across more physical qubits can, for the first time, actually reduce logical errors. So what does this actually mean for 2050? Don't expect a quantum laptop on every desk. Instead, these powerhouse machines will be accessed through the cloud, plugged into a hybrid workflow with classical supercomputers. A researcher will pose a problem, a classical computer will break it down, and then it will hand off the impossibly hard parts to the quantum processor. Artificial intelligence will be the smart conductor of this whole orchestra, managing the entire process. The 2050 vision is one of ubiquitous, invisible quantum artificial intelligence assistants. Your doctor might consult an artificial intelligence that runs quantum simulations to design your treatment. City planners could use a quantum artificial intelligence hybrid to design traffic systems that flow with zero congestion. And scientists will have a tool to model climate change with frightening accuracy, helping them invent new carbon capture technologies at a speed we can't even imagine right now. Even the road to 2050 is long and the challenges are huge. Quantum computing is still in its early days, a technology that demands extreme cold, total isolation from the world, and engineering precision that pushes the very limits of what we know. Yet the direction is clear. We are moving out of the era of physics experiments and into an era of engineering discipline. The convergence of quantum computing and artificial intelligence is more than just the next leap in processing power. It's a whole new way to discover. By using the fundamental laws of the universe to compute, we're building a tool that can finally understand the universe in its native language. This hybrid intelligence won't just improve our world. It will let us simulate, design, and build new realities. The revolution won't be televised, it will be computed, and by 2050, its impact will be woven into the very fabric of our lives. The possibilities are almost endless. From medicine to materials science, this technology is going to reshape our future. So I have to ask, what quantum artificial intelligence breakthrough are you most excited to see by 2050? Let me know your vision in the comments below. And if you want to stay ahead of the curve on the tech that's changing everything, make sure to subscribe and share this video.